Okay, so good morning classmates, and especially to you sir, Raymond Indagan sir, good morning. So in this morning, I am going to report 3 reports and my daily reports on trigonometry, which we can find it in page 13, example 6, and page 49, number 1, 2, 3, by Bailey and Hostage. And in trigonometry by Leal, we can find it in page 365, example 4. So let's move on to our first topic for this morning. So our first topic in this morning, we can find it in page 13, example 6. And it's all about how we're going to find the number of degrees in one region, or what is the equivalent of one region in degrees. So first, we're going to talk about, or let's have a little background about region. So region, it is a unit of plane angular measurement that is equal to the angle at the center of a circle subtended by an arc whose length equals the radius, or approximately 57.3 degrees. So now, let's move on, or let's find out the illustration about region. So as we can see in the illustration, there is one radian and there is a radius. Length is equal to radius. So but the main question in this problem, or in this report, is what is one region in degrees? So this is the reason behind why one region is equal to 180 degree over pi. Here what really it is. Let's go back to our illustration, and this is our illustration. We all know that the full rotation of a circle has 2 pi regions, and the full rotation of the circle in degrees is 360 degrees. Now, the question is, what is the equivalent of one region? Or is it true that the equivalent of one region is equal to 180 degree over pi? So, because we're talking about the number of degrees here, or the number of degrees in one region, so let us use the full rotation of 2 pi regions in the full rotation with 360 degree. Now, as we can see in the right side, in this illustration, 2 pi regions is equal to 360 degree, and one region is questionable, or we're going to find out if it is true that the equivalent of one region is 180 degree over pi. Then now, one region is equal to 360, which is the full rotation of a circle in degrees, and over 2 pi, which is the full rotation in the regions, or full rotation using 2 pi regions, is equal to 180 degree over pi. So 360 divided by 2 is equal to 180. So therefore, one region is equal to 180 degree over pi. Now let's find out its degrees, or what is the degrees of one region. Now, example 6. Find the number of degrees in one region. If one region is equal to 180 degree over pi, so therefore 180 degree over 3.1416, which is the equivalent number of pi. Now 180 degree divided by 3.1416 is one region is equivalent to 57.2958 degree. Okay. So now let's move on to our next discussion, or our next report in trigonometry by Bailey and Hostage in page 49, number 1 to 3. And we are going to talk here on how we are going to find the reference angle. But for that, what is reference angle? Reference angle is the positive acute angle made by terminal side of the angle and the x-axis. So let's have the illustration on how we're going to find the reference angle. Okay, as you can see, we have the Cartesian plane, the y-axis and the x-axis. And as you can see also, we have the quadrant 1, quadrant 2, quadrant 3, and quadrant 4. In quadrant 1, it exists between 0 degree and 90 degree. In quadrant 2, it exists between 90 degree and 180 degree. And in quadrant 3, it mainly exists in 180 degree and 270 degree. And in quadrant 4, 270 degree exists. In quadrant 4 exists 270 degree and 360 degree. Now, how we are going to find the reference angle? In finding the reference angle in quadrant 1, the reference angle, let's look on the right side, or the table, my illustration in table form. In quadrant 1, the reference angle is equal to the angle in quadrant 1 that exists between 0 degree and 90 degree. In quadrant 2, in finding the reference angle, we use 180 degree minus the angle in quadrant 2. And in quadrant 3, we need to use the angle in quadrant 3 minus 180 degree. And in quadrant 4, we need to use 360 degree minus the angle in quadrant 4. So, let's move on how we're going, or let's have the actual, or how we are going to find the reference angle of each of the following. So, 120 degree, number 1, 120 degree. How we are going to locate, or how we are going to find if it is belong in quadrant 2. So, as we all know, that in quadrant 2, it exists between 90 degree and 180 degree. So therefore, 120 degree lies in quadrant 2. So therefore, 180 degree minus the angle of quadrant 2 is equal to 180 degree minus 120 degree is equal to 60 degree. So therefore, 60 degree is the reference angle of 120 degree. Okay, in number 2, 210 degree. So let's find out if where it belongs, or what quadrant it belongs. So in quadrant 3, it states that, or it exists between 180 degree and 270 degree. So therefore, 210 belongs to quadrant 3. So the angle in quadrant 3 minus 180 degree is equal to 210 minus 180 is equal to 30 degree. So therefore, the reference angle of 210 is equal to 30 degree. Now, in number 3, what if it has negative, or in number 3, negative 330? How we are going to solve it? So first, we are going to make it positive to find out what quadrant it belongs. So let's add 360 degrees, the full rotation of a circle, which is 360 degrees. So negative 330 degree plus 360 degree is equal to 30 degree. So 30 degree exists in quadrant 1, because you all know that in quadrant 1, it has 0 degree and 90 degree. So therefore, it states in the table that we took while ago, it states that in quadrant 1, the reference angle is equal to the angle in quadrant 1 that exists between 0 degree and 90 degrees. So therefore, 30 degree is the reference angle of negative 330 degree. So let's move on to our next discussion, or our next report. It is on Leal, page 365, example 4. And we are going to talk here the example 4 on how we are going to find the products and quotients involving negative radicands. Okay, here's the situation is, multiply or divide as indicated, simplify each answer. So in situation A, the square root of negative 7 times the square root of negative 7. And B, square root of negative 6 times square root of negative 10. And then C, square root of negative 20 over square root of negative 2. And D, square root of negative 48 over square root of positive 24. So how we are going to find, or to solve the negative radicands? So to solve this, we need to use I, or I stands for imaginary number, because remember, we can find a number that when we square it, we get a negative, because any number, when you multiply by itself, it always gives us a positive. So we bring in I, which stands for imaginary number, to deal a situation like this. So it all addresses on this. Square root of negative 1 is equal to I. So we're gonna use that to allow us to simplify the situation where we're trying to take on or where we're trying to square root of a negative number. So here is the solution. In the situation A, square root of negative 7 times square root of negative 7. So I, which stands for negative 1 or stands for imaginary number, so I square root of negative 7 times I square root of positive 7 is equal to I squared times close and open parenthesis square root of 7 squared is equal to negative 1. So is equal to negative 1 times 7 is equal to negative 7. And in situation B, negative 6 square root of negative 6 times square root of negative 10 is equal to I square root of 6 times square root of 10. So 6 times 10 is equal to 60. So I squared times square root of positive 60 is equal to negative 1 times 7 times 15 is the factor form of 60. So therefore 4 times 15 is equal to 60. So this is the factor form of 60. Now negative 1, what is the square root of 4? 2. So therefore negative 1 times 2 is square root of 15. Negative 1 times 2 is equal to negative 2 square root of 15. So that is the answer in situation B. Now let's move on to the situation C and situation D. In situation C, square root of negative 20 over square root of negative 2. Now, how we're going to find it or how we're going to simplify it? I square root of 20 over I square root of 2. So we need to cancel out I. Then the remaining is square root of 20 divided by 2 or square root 20 over 2. So therefore, the result is square root square root of 10. And in situation D, square root of negative 48 over square root of positive 24 is equal to I square root of 48 over positive 24. So therefore, I 48 divided by 24 is 2. So therefore, I square root of 2.